In this example, we're going to solve this system of nonlinear equations. Well, it looks like our first equation is going to generate a line, but our second equation is going to generate a parabola because it's degree 2. Okay, so we know we have a couple of options here for the solutions that we're going to get. We could get 0 solutions if our parabola and our line have no points in common. Or we could get 1 solution if our line and our parabola are tangent, right there, this line is tangent to the parabola. Or we could get 2 if the line, passes through the parabola and hits it twice like this. So we've got some options as to what our answers will be. So 0 answers, so no solution, or 1 solution, or 2 solutions. So let's go ahead and tackle it and see how this one comes out. It looks like substitution will be our best bet because our x in our first equation is just 1x and our y is negative 1y. So either one of those would be easy to solve for. Our second equation has powers of x, so probably I'll solve for y and plug it in so I can have only x's, and then I'll probably end up factoring it. So let's go ahead and look at this first equation. Let's solve for y. So if I take this negative y and I put them over on the right side, I'll have positive y. And then I'll take this positive 3, move them to the left, and I'll have a negative 3. So it looks like y equals x minus 3. So let's go ahead and plug that into the y right there. And it looks like I have x minus 3 equals x squared plus 3x minus 11. All right, well, this equation is easy enough to solve. I'm going to subtract x and add 3 to both sides. Since I'm solving this quadratic, I need it to be equal to 0. So 3x minus x is a positive 2x, and negative 11 plus 3 is negative 8. This will factor pretty nicely. Numbers that multiply to make negative 8 that add to make positive 2, so plus 4 and minus 2 will be our factorization. Because we have this factorization equal to 0, I'll use the 0 property of multiplication and set each of these factors independently equal to 0. So x equals negative 4 and x equals positive 2. So 2 values, okay? So let's go ahead and plug them back in to our x minus 3 equals y. So I'm going to go ahead and write it down here, though, where we have room. So y equaled x minus 3. So when we plug in negative 4 for x, I'll have y equals negative 4 minus 3. So y will be negative 7. And this ordered pair will be negative 4, negative 7. All right, well, when I plug in x equals 2, I'll have y equals 2 minus 3, so y equals negative 1. So this ordered pair will be 2, negative 1. So here are my 2 ordered pairs, which will be the solutions of this original system with nonlinear equations.